All right, so example 6 is similar to one of the examples we saw before in the increasing, decreasing intervals, and that we're back to trig. Yay! Different, in that particular problem, we were given a function where we had to take a derivative, and in this case, we've been given the derivative function. And then we wanted, of course, intervals of increasing and decreasing, and now we want our local extrema. We still, of course, have that limitation of the 0 to 2 pi because we know this thing is periodic, and therefore there would be like an infinite number of them, and we don't want to deal with that work. So let's go forth and deal with this particular problem. We know first things first, we need our critical values. Cosine is continuous, smooth, so there are no undefined values here, but we can set that equal to 0. So 2 cosine of x plus the square root of 3. So all we have is that shift upward of square root of 3 and then that stretch of 2, which if you want to use like trig language, we have a midline at square root of 3 and we have an amplitude of 2. No phase shifts, nothing messing with my period because our argument of cosine is just x. But anyways, solving this, we'll go ahead and set, we need to isolate our 2 cosine of x. Technically, we need to isolate our cosine of x. So we end up with root 3 over 2 negative is equal to our cosine of x. And just like many of our polynomials factor, many of our trig values end up on the unit circle when we're in math class. So we have to think about our unit circle or our graph. You know me, I'm going to do both. So unit circle wise, root 3 over 2 is the shorter of the two, right? Because cosine is 1, then it becomes just slightly less than 1. But I need it to be negative, so I'm looking at a reference angle of this pi over, I have to think in my brain, 6 in our quadrants 2 and 3. So our x's are going to be 5 pi over 6 and 7 pi over 6. Now again, we could also think about our actual graph of our cosine function. That graph of the cosine function starts at 1, comes down to 0, goes down to -1, and back up. And we want the values very closest to that 1. So we kind of think about where those are, right? This is happening at pi over 2. This maximum value is happening at pi. We want to be really close to that pi. That kind of helps us in the same way of really visualizing things, especially if the unit circle just doesn't like stick in our brain, as it doesn't stick in mine. All right, so those are our 2 potential local extrema. We know based on the cosine graph, they're definitely going to be changing signs. Especially here, if I realize about this graph, all I have is a shift and a stretch, right? Nothing is changing. But we could go ahead and check if we wanted to. Let's go make ourselves a beautiful number line. We have 5 pi over 6 and 7 pi over 6. We could either test, I mean, I kind of know from that graph it's going to be plus, minus, plus, but let's just test something. Let's plug in, say, pi. So then we'd have 2 cosine of pi plus the square root of 3. Cosine of pi is -1, so we'd have -2 plus the square root of 3, which is negative. Right? The square root of 3 is less than the square root of 4, so we've added less than we subtracted. Terrible explanation, but you know, type it into a calculator if you can believe me. We could, of course, try some values on the other end. We could try like our 0. So that's cosine of 0, which is 1. So we'd have 2 times 1 plus the square root of 3. That's definitely positive. And hopefully we recognize that cosine does cross at 0, so this makes sense. And then we might just believe me by now. But of course, you could plug in any other value you wanted. There you go. So plus, minus, less. Oh, we need local extrema. We could say here, we know we have a positive to negative, a relative max at whatever m of what the heck is this? 5 pi over 6 is, I shouldn't say at, it's a relative max of, because that's the value, at x is equal to 5 pi over 6. Because of that, I'm not going to write this time. And then we went from negative to positive, so we'll have a relative min of whatever the value of m of 7 pi over 6 is. We don't have m, so we can't know this. At x is equal to 7 pi over 6. Oh, it just said find values of x. Bah. So I can just write that. Relative max at and relative min at, because of what we have in that beautiful sign table up above.